Hello, good morning children. You're welcome to e-learning class. We are going to learn mathematics and the topic is lines, angles and triangles. First of all, I want to know what a line is, a straight line. A straight line is the shortest distance between 2 points. Just like this marker I'm holding here, it's a straight line. Now, it has, if you want to represent it, mostly we use ruler to represent a straight line. You draw with a ruler. So the starting point is point A, and this is point B. This is a straight line. So we're going to look at types of lines. The first type of line that we have is what we call a parallel line. What is a parallel line? It's two or more lines with equal interval between them and they never meet. Look at, for example, if I want to draw parallel lines, this is how to draw parallel lines. These are two or more lines, can be two, can be more than two. And the important thing is that these two lines can never meet. Like our electric wire that we use, they are always parallel. Then the next type of line we want to look at is the perpendicular line. When two straight lines intersect means to cross each other. And the angle between them is always 90 degrees. For example, I'm going to draw it here. This is a perpendicular line. I first of all draw a vertical line, and another line which is called horizontal line is crossing it at the center. And the angle between them is always 90 degrees. So this is what we call a perpendicular line. Then the next type of line is very simple, which we have already known, is the vertical line. It's a line that is drawn up to down. If I draw a line from up down, that is a vertical line, while the next line, which is drawn sideways, is the horizontal line. Now, these are the types of lines that we have. The next subheading that we're going to look at is what we call the angles. What are angles? These are the amount of turning or rotation from a fixed point. It is always measured with an instrument that is called protractor. In the last slide, I showed you what a protractor is. And we normally use protractor to measure angles. And angles are measured in the unit called degrees. And degrees is written this way. So, for example, I want to write 30 degrees. This is 30 degrees. So the unit of angles are written in degrees. So we want to quickly look at types of angles. The first type of angle that we have is the one we call acute. Acute angle. What is the meaning of acute angle? Is the angle. This sign means angle that is always less than 90 degrees. It's less than 90 degrees. So let's look at this. I'm going to draw the acute angle. Assuming that this is a straight line. So this middle is the 0 point. So if I'm using protractor, this is 90 degrees. So any line between 0 to 90, 89 point something is acute. So I can take this to be my acute angle. So this is acute. I can take this as my 30 degrees. So 30 degrees, 40 degrees, 50, 60, 70, 80, till you get to 89. They are all acute angle. So this is how to draw an acute angle. Then the next type of angle we're going to look at is the number 2, which is the right angle. And the right angle is always equals to 90 degrees. So let's assume that this is our straight line. So right angle is equals to 90 degrees. If we use the protractor, as I said earlier, you place your protractor here, you're going to see that this place is going to be 90 degrees. So any angle that is equals to 90 degrees is called right angle. Then the next type of angle we want to look at is the obtuse angle. We say that obtuse angle is greater than 90 degrees, but less than 180. That is the important point that you need to know. The most important point is that it must be less than 90, must be greater than 90 degrees, but less than 180. So if I want to represent my obtuse angle, let's assume that this is my 90, which we have already known. So anything from here, I'm just going to start here from 0, from 90. So any point after 90 is obtuse. So I can indicate this place as my obtuse angle. So from here to this place I can take this place to be 120. So 120 is obtuse. 110 is obtuse. 130 is obtuse. 155 is obtuse till 179. So maybe when it is less than 180, you know that it is what? Obtuse. So this is an example of an obtuse angle. The next angle we're going to look at is the reflex angle. The reflex angle is an angle that is greater than 180, but less than 360. So this is our straight line. Remember, this is always 0. This is 90. This is 180. And this is 270. So my angle starts from here, 90, come to 180. So any point from here can become my what? Remember, this is the 0 point. So this is my reflex. Remember, it is greater than 180, but less than what? 360. This is my 360, and this is also 0. So what that means, 190, 199, 200, 240, 250, all of them are all reflex angles. And the last type of angle I want to talk about is the revolution. When we say angle is revolution, it means that that angle is the angle of a circle. Sometimes we would call it angle at a point. So this is a circle. This is how a circle looks like. Now this circle can be divided. We can divide into 4 equal parts, which is called quadrants. This is the first quadrant, which ends at 9. This is 0. This is 180. And this is 360. This is 4 quadrants. Now, the angle, if for example somebody moves from here, turn to 90 to 180 to 360, 270, and come back again to 360, that person has done a revolution. All right, let's look at the triangles. We're going to look at what triangles are. We want to look at a triangle. We say that a triangle is a polygon with 3 sides and 3 angles. A polygon, when we talk about polygon, we have different types of polygon. Like a triangle has only 3 sides and 3 angles. We have other polygons. We have the one that has 4 sides and 4 angles, which is rectangle. We have square. We have pentagon, which has 5 sides. We have hexagon, which is 6, heptagon, which is 7, octagon, which is 8, nonagon, and decagon, and so on and so forth. So we want to look at types of triangles. The first type of triangle that we have is the one we call scalene triangle. Scalene, it has 3 sides, and the 3 sides are different. They are not the same. So this, if for example I want to draw a scalene triangle, I will draw something like this. This can act as my scalene, or take something like this. You see that this one is longer than this one is second, and than this. So what I'm trying to say in Excel is that the 3 sides must be different in scalene. No side is the same. So in scalene triangle, all the sides are not the same. They are not equal. Then the next type of triangle we want to look at is the one we call isosceles. Isosceles triangle. In isosceles triangle, 2 sides are always the same, but one side is different. For example, I want to draw a isosceles triangle. This is an example of an isosceles. This side are the same, while this side is different. So this is an example of an isosceles triangle. The next type of triangle we want to look at is the equilateral triangle. We say that in equilateral triangle, all the 3 sides are equal. The 3 sides are the same. So that is an example of an equilateral triangle. Now note this. We say that complementary angles, all of the angles sum up to what? To 90 degrees. In the next class, I'm going to explain what complementary, because of time, I'm going to explain what complementary angles are. But take note of this, that complementary angles always sum up to 90 degrees. 2. supplementary angles sum up to 180. 3. Sum of angles on a straight line is always equals to 180 degrees. And in Pythagoras, we want to look at some of the examples. Now, what I'm saying here is this, for example, you may be asked to find this. Look at the example here. I'm giving you a triangle of this nature. Now, this is the longest side. This longest side, we normally call it hypotenuse. Hypotenuse. Now, this side is the angle. The side that is opposite the angle, as the name implies, is called the opposite, while the remaining side is called adjacent. Now, there was a man that came out with this theory, and the name of that man was Pythagoras. He came up with this, that the sum of this side of the triangle is equal to the hypotenuse. Let's give this hypotenuse, let's say C, and this is A, B. So Pythagoras now say that C is the square root of A plus B. So that was what Pythagoras came up. We just want to use that and solve this example. The example is given here. So we want to take this as our 3m, while this is 4m, and this is what? X. So our x will be equals to square root of 3 square plus 4 square. So this will give us square root of 3 square is what? 3 times 3 is 9. 4 times 4 is what? 16. So we now have square root of 25. And the answer gives us what? 5. And that is how to solve this example. Finally, let's look at the last example, example 2. You are given this. This side is given 50 degrees. This side is given, and this side is not given. It's unknown. And this one goes to this. The third rule I gave on the board, we say that sum of angle on a straight line, this is a straight line, is equals to 180. So we need to sum, we need to add all these angles and sum it equals to 180. That's what we're going to do now. So when something like that is given, what you do is 50 degrees plus 60 degrees plus m degrees. You sum everything to what? 180 degrees. So from here, we want to collect like terms. We take the unknown to one side. 50 plus 60 is going to give us 110 degrees plus m equals to 180. So we collect like terms. M degrees will be equals to 180 degrees. When this 110 crosses this equal sign, it becomes negative. So now we want to minus this. 180 minus 110. So this gives us 70. That means our m equals to 70 degrees. That is to say this place is 70. If you add the whole of this, it's going to sum up to 180. So we're going to continue from there in the next class. Please take time to study this from the beginning to the end, so that in the subsequent classes you will not find it difficult. I believe when you study it in detail carefully, you will not have any problem in subsequent classes. Thank you very much.